So in this video, I'm going to show you a couple of examples applying Rolle's theorem. So in this first one, we have a quadratic function, and we want to verify that the criteria for Rolle's theorem is satisfied, and then find at least one c such that f prime of c equals 0. So first, I want to note that, like I said, this is a quadratic function, so this is the graph of a parabola. We know that that is continuous over any interval, and we also know that it's differentiable over any open interval. So those two pieces of the criteria for Rolle's theorem are satisfied. So we just need to check the endpoints of this interval. So let's make sure that the output for the endpoints of this interval are the same. So we're going to look at f of 0, and that's going to be 0 squared minus 5 times 0 plus 3, which is 3, and make sure that we get the same when we put in 5. So we'll get 5 squared minus 5 times 5 plus 3, which is 25 minus 25 plus 3, which also equals 3. So our outputs are the same. So Rolle's theorem has been, the criteria for Rolle's theorem has been satisfied. So now we can find that f prime of c, because we know it exists, or that c, sorry. So we're going to find f prime of x, which is 2x minus 5. And then we're going to set this equal to 0 and look for c. So if I add 5, divide by 2, I will get 5 halves, which is the same as 2.5. And notice that that 2.5 is in the interval from 0 to 5. So this is the c I was looking for. In this second example, we have a more complicated function. And if you were to look at this in your calculator, it's going to look a little bit like that, where this is 0 to 4. So it is continuous over the interval from 0 to 4, and it's differentiable in the open interval from 0 to 4. I have no breaks, and I have no sharp corner points. So we really just need, again, to check the endpoints of the interval. So looking at f of 0, we have 0 times the square root of 4 minus 0, but 0 times anything is 0. And then f of 4, which is going to be 4 times the square root of 0 minus 0, which is 4 times the square root of 0, which again is 0. So the outputs for the endpoints of our interval are the same. So we know that the c that we're looking for exists, so let's go find it. So we're going to find the derivative, and for this function we're going to need to use the product rule. In fact, I'm going to first rewrite this so that I can use the power rule when I'm finding the derivative. So applying the product rule, I have the first times the derivative of the second. So I'm going to drop that 1/2 down in front, decrease it by 1, and then don't forget to apply the chain rule on this inside piece here, and the derivative of 4 minus x is going to be -1. Plus the second times the derivative of the first. So 4 minus x to the 1/2 times the derivative of x, which is 1. So what we